Properties of groups. Prove that identity element of a group is unique. Here, G is a group 1 omega omega square. This is a group with respect to multiplication. In this group, 1 is the identity element. If 1 is identity element means omega is not an identity element. Omega square is also not an identity element. That means in a group G, only one element becomes an identity element. That is the meaning of this statement. Proof. Once observe the proof, consider G comma star be a group. Group means it satisfies closure law, associative law, existence of identity element, existence of inverse element. Here we want to show that only one element is the identity element. But here we are considering two identity elements. E and E dash be two identity elements in a group G comma star. After that, at the end of the proof, we show that E equal to E dash. That means there exists only one identity element in every group. So once check what is identity property. If A is an element of G, A star E equal to A, E star A. This is the identity property. That means if you multiply any element of G with identity element, you are going to get an element itself. Here you can observe, first of all, we are considering E is the identity element. E dash is an element of G. That means A belongs to G is here. In the same way, we are taking E dash belongs to G. Substitute A equal to E dash. Then we get E dash star E equal to E dash E star E dash. So take this as equation 1. This statement is true when E is the identity element. Now consider E dash is the identity element. E dash is the identity element. And E belongs to G. And consider E belongs to G. That means substitute in the place of A, E, in the place of E, E dash. Then we are going to get E star E dash. E dash is the identity element. That's why answer is E. E dash star E. This is equation number 2. Once again, observe. This is identity law. That means A belongs to G. A star E equal to A equal to E star A. Here E is the identity element. Why we are taking E as identity element means any element star E equal to any element. That's why we are taking E as identity element. Here we are considering E and E dash are two identity elements of G comma star. First of all, we are assuming E is the identity element. E dash is an element of G. Here we are not taking E dash as identity element. E only identity element. So, in this line, we are going to substituting A as E dash. So, E dash star E equal to E dash equal to E star E dash. Take that as equation 1. In the next step, we are taking E dash is the identity element and E is an element of G. In the same line, we are going to substituting E as E dash, A as E. Then we are going to get equation number 2. Observe E dash star E, E dash star E, E star E dash, E star E dash. This quantity equal to this one equal to this. So we can easily say that E equal to E dash. Therefore, there exists only one identity element in a group G. Next property, inverse of an element in a group is unique. For example, if I am considering 1 omega omega square as a group with respect to multiplication, then the inverse of 1 is 1. The inverse of omega is omega square. The inverse of omega square is omega. Observe once, the inverse of an element in a group is unique. That means the inverse of 1 is only 1. If 1 is the inverse of 1 is 1, then omega and omega square are not inverses of 1. If omega inverse is omega square, then 1 and omega are not inverses of omega. If the inverse of omega square is omega, then 1 and omega square are not inverses of omega square. That means the inverse of any element is again a single element only. Now observe the proof. Let G comma star be a group. Group means it satisfies closure law, associative law, identity law and inverse law. So by using identity law, we are taking E is an identity element in G. And also A is any arbitrary element of G. That means we are taking any element of G randomly. If we prove the theorem by taking an element A belongs to G, then it is applicable for every element of G. So A is any element of G. For this A, we are taking B and C are inverses. So if B is the inverse, by using if B is the inverse of A, by using inverse law, we can say that B star A equal to E and also A star B equal to E. If C is the inverse of A, if C is the inverse of A, then C star A equal to E equal to A star C. So, the multiplication of an element and its inverse is equal to identity element. Once observe in this group, The inverse of 1 is 1. So multiplication of these two is identity element in that group. Omega and omega inverse is omega square. Multiplying, we are going to get omega cubed. The value of omega cube is 1. Next, omega square and its inverse, that is omega, again equal to omega cubed. That means again we are getting identity elements. That means the inverse of an element into element is equal to identity element. Inverse star an element equal to identity element. So next, take this as equation 1, take this as equation 2. Now our aim is to show that B equal to C. That means there is no two inverses for single element. There exists only one inverse for any element. For that, we are using identity law. Identity law says element star identity element equal to element only. Now, substitute the value of E. Observe A star C equal to E. Replace E with A star C. Next, we can use associative law because G comma star is a group. So by using associative law, we can write B star A star C as B star A star C. Next, we know the value of B star A, that is E only, E star C. Again, by using identity law, identity element into any element equal to any element. So, we are getting B equal to C. At the starting, we are taking B and C are inverses of A. Finally, we proved that B equal to C. That means for one element, we have only one inverse. Here they mentioned, since A was chosen as an arbitrary element of G, it follows that every element in G has a unique inverse in G. Here we take A as an element of G and we show that B equal to C. If we take any other element of G, then also we can show that B equal to C. So next property, prove that the inverse of an element of a group is the element itself. That is to prove that A inverse whole inverse is equal to A itself. For all A belongs to G. That means if we take A belongs to G, A inverse whole inverse equal to A. If we take B belongs to G, B inverse whole inverse equal to B. For the remaining elements also, this one is true. Now we want to prove this one. So take A inverse whole inverse, which is equal to, by using identity law, we can write A inverse whole inverse star E. Once observe element star identity element equal to element itself. Next, in the next step, we are writing A inverse whole inverse as it is, but we know the value of E, that is A inverse star A. E value is A inverse star A. Next, again by using associative law, A inverse whole inverse star A inverse star A. which is equal to, observe, element. Inverse of this element means that is E only. E star A is equal to A. So, element in here once observe, element is A inverse. The inverse of that is A inverse, whole inverse. Element star, inverse of that same element equal to E. That's why I am replacing this with E. Again E star A, element star, identity element is element only. So, therefore, what we proved? A inverse, whole inverse equal to A. So, if we take B belongs to G, B inverse whole inverse is also B only.